Hi, CS430. Let's talk about parameter passing modes to subprograms. So this is an important part of how a subprogram operates with the outside world that is calling it. Because to use a subprogram, like my little function foo over here on the right, we both need to be able to get input into it and get input out of it. And one method that you are quite familiar with for getting input into a function is through parameter passing. But what we're going to see today is that in some languages, parameter passing becomes a two-way street. And so we're going to talk about the different ways that parameters can be used to give both input and output from a function. In languages that use these other modes, functions don't necessarily need to return values. They can also give values back through their parameters. So let's look at the three different types of semantics for parameter passing. So the first one that you're all very familiar with is in-mode parameter passing. This is, of course, what Java does. And here in in-mode parameter passing, parameter is input to the subprogram. Another method is out mode. Another set of semantics is out mode parameter passing. And here the parameter is not input, it's actually output from the subprogram. So a parameter is output from a subprogram. And then the mixture of these two is called in-out mode parameter passing. And for this semantics, the parameter is both input and output. Parameter both input and output. So let's look at a hypothetical modification to a fairly Pythonic language over here. The way that I've done this is A is an in-mode parameter because it has no decoration. B is going to be an out-mode parameter because of the decoration out, or the keyword out here. And C is going to be an in-out parameter. And we're going to see how this affects each of these. So the way to think about it is with in-mode parameters, you're used to this. When I call the function here, foo, with the in-mode parameter A, I'm copying the value from X into A, right? With the out-mode parameter B, I'm not actually copying the value of Y into the value of B. In fact, I'm doing the opposite. Whatever value foo sets to B is going to be copied back into X. In an out mode parameter, you are not allowed to use it in an expression here in the main part of the function, and this is because it's only for output, it's not for input. So it's not, B does not have a value inside foo until it's been assigned. And then at the end, the actual parameter that I've got down here, Y, will take on the value of B. And then in-out mode is, of course, a mixture of these two, where it's going to be used as both input to the function and output from the function. Okay, so let's look at a slight modification to a fairly Pythonic language over here. And what I've done is I'm thinking of A as an in-mode parameter, even though I haven't put a keyword for it. B is an out-mode parameter, and C is an in-out parameter. And the thing to notice is that X is going to go, the value of X is going to be passed into A. So with an in-mode parameter, the actual parameter goes into the formal parameter. On the other hand, with B, the value of B is not the value of Y is not being passed into B. In fact, it's going the other direction. The formal parameter B is going to come back out of the function and go into the value of Y when the function returns. So at the end of the function, Y's value will have changed, but B is not taking input from Y. And then C is both of them. It's both taking input and from Z, and it's going to set the value of Z at the end if there's a change to C. And so one thing to note is with an out mode parameter, you can't use it in an expression until you've assigned to it because it's not taking a value from the outside world. So notice here, I have to assign to B before I use it. I couldn't, in this line, say like temp equals B plus C or something like that. This would result in an error because B hasn't been initialized. It's not getting a value from Y, it's giving a value to Y. Okay, so let's run this code and see what's going to happen. And the thing to note is that we'll talk more about implementation details in a moment, so I'm going to be a little fluid on exactly how these things are implemented, but I want to kind of give you the general idea. So let's assume that this is sitting in some stack frame I'm going to call main, and then of course main is going to call foo right here, and so initially I need a stack frame for main, I'll put down at the bottom, and it's going to have its variables x, y, and z, and so maybe something like this. X is initialized to 3, y is initialized to 4, and z is initialized to 5 as per that line of code. And now what I'm going to do is call foo, and I'm going to just, for the purposes of dealing with the in-out, we'll do A as we normally would. Again, we're going to talk about exactly how these are implemented shortly, but with B, I'm going to treat it sort of like a reference, and with C, I'm going to, maybe we'll copy the value up for now. Okay, so I'm passing in X for A, which is 3. I'm doing an out mode for B, which is going to go out to Y, but it is going to need a value. So I'm just putting this here to remind me that this is going out. This is not actually a reference. Again, we'll talk about how these are done in a minute. And now, and then for passing in the value of Z for C. And so let's run the code. I'll make changes in a different color. So now we're running foo, and foo says, okay, B gets the value of A plus C. So it's going to be 8. Then C gets the value of 0, so this changes to 0. Then A gets the value of 7. This changes to 7. And now we return, so there's an implicit return here. And because B and C are out mode parameters, the actual parameters that I am sending, that I've mapped to the formal parameters B and C, now need to have the values that B and C have. So Y is going to change to be 8, and Z is going to change to be 0, because I'm getting output from the fact that I passed both Y and Z in to parameters that have out mode. And so then foo is now going to be popped because I'm done running it. And the output of my function is, or my print statement here, is going to be 3, 8, 0, printing out x, y, the current values of x, y, and z. So how do we implement these things? Well, there are 5 ways we're going to look at, and the first is one that's very familiar to you because this is what Java does. It is pass by value. And here, this is an implementation of in-mode parameter. Now, Java's a little tricky because it's passing references by value, but let's not worry about that right now. Pass by value nonetheless. And in this case, this is in mode, so on function invocation, we're going to do something, and what we're going to do is copy the value of the formal parameter, copy the value of the actual parameter into the value of the formal parameter. So on invocation of the function or subprogram, copy value from actual to formal parameter. I'll leave off parameter because I don't have enough room there. The next method is an implementation of out mode, and it's just the inverse of pass by value. So this is called pass by result. And the idea is when the function returns, we're going to copy whatever the final value is of the formal parameter inside the subprogram back out to the actual parameter. So for instance, with foo here, when we return at this point in the program, we're going to take whatever the value of b is and copy it into y. But that's not going to happen while the function is running, but when it returns. So here, pass by value result is on subprogram return, copy value from formal to actual. Okay. And then an obvious way of implementing in-out mode is to do both of these. So this is sometimes called pass by copy. It's also sometimes called or pass by value result. And it is, you can hear my children in the background, but there's nothing I can do with that. It is simply do both of the above. So at invocation, we're going to copy a value from the actual to the formal. Then we're going to do whatever the work of the subprogram is. And once the subprogram is ready to return a value or return from the subprogram, we're going to pass a result back into the parameter. And so that gives us a nice way of doing all three of these. Then there are actually a couple more ways of doing in-out, and so we're going to look at those next. The next method of doing in-out mode, let's put this here, is called pass by reference. And here, what we're going to do is when we create an in-out mode, like C, we don't actually copy values. We make C a reference to its actual parameter. So here, formal parameters are references to the actual parameters. And we'll see an example of this in a moment. The final method for doing in-out parameters is called pass by name. And it's a little difficult to give a one-liner definition here. An example that we'll do in a moment will do a much better job. But you can think of this as sort of copy and pasting the expression from the actual parameter into the formal parameter so that that expression can be evaluated multiple times. So it's really, and it's not quite copy and paste, but it's very similar to C macros. If you're familiar with C macros, and sort of like passing the code of the expression, code of the actual parameter into the formal. And we'll see sort of what that looks like in a moment. Okay, so let's see what this looks like in action. So look at the code on the right that I've got here. I've got a function foo that takes in 4 parameters, a, b, c, d, and a function main that initializes a list and then also a variable y, and then it calls foo passing a bunch of parameters and prints them out. And we're going to set some implementations here. So a is going to be pass by value, b is going to be pass by copy, c is going to be pass by reference, and finally d is going to be pass by name. Okay, and we're going to track what happens in a sort of in the stack, given that I'm making up details of a mythical language that allows me to do all of these things at once, right? Okay, so the first thing we're going to need is a stack frame for main, and that frame is going to have all of the locals there. And for this language, we're just going to assume nothing is heap dynamic. So we're going to go ahead and put X into the stack. I'm committing some grave sins here by not making things grow from top to bottom, but that's okay. So we have 4 slots in X, and then we also have a variable Y, and so our stack looks something like this with the values 1, 2, 3, and 4 in X, and Y is equal to 2. And so that takes care of this line 1 and line 2 of main, and so now we are going to call foo. And so in order to call foo, we need to set up a stack frame for foo. And foo has a, which is passed by value, and so if we look at what the actual parameter that we're passing into the formal parameter a is, we're passing the value of x sub 0, which is simply 1. So we pass by value, which means that we copy the value up while we're setting up the stack frame to call foo. The next parameter b here is passed by copy, which means that at the beginning we're going to copy the value of x1 up. And so we go ahead and copy the value of x1, which is currently 2, into b. C is passed by reference. So this is actually a reference, and maybe we'll draw it with a green arrow here. A reference to the actual parameter y. And so this is really a reference to this value where it is in memory. And so when I execute this line of code, there's an implicit dereference, just like there is with the reference type. And so this is really not accessing C's memory location, but the memory location that C is referring to, which is y. And so when I do the C+1 here, we're going to see the value of y increase, right? It's not. And then finally, we have D. And D, now I don't have a good way of drawing this, and the way that I've kind of decided to do this is for pass by name. Let me do it in a maybe a different color here, say some kind of pseudo gray, and we'll put x sub y in, because it really means the code x sub y, so that when I evaluate it, it is going to use the current value of x and the current value of y. It's not evaluating this now, it's waiting until D is used to evaluate that code, and it's bringing with it its context, so that x really means this array and y really means this variable here. Okay, so keep that in mind as we move forward. All right, so now we need to execute the lines of code. So the first thing we do is a plus equal to 1, and so this now becomes 2. The next thing we do is b plus equal to 1, and b also just is a normal variable at this point, or a normal parameter, except that it's going to be copied back at the end, so this becomes 3. Then we're going to execute c plus equal to 1, and again, we're doing an implicit dereference here, and so the value that's getting modified is y's value, which goes up to 3. And now we finally get to d plus equal to 1, and the way to think about it is it's x sub y plus equals 1, where that's now being evaluated at this moment in the original context of the actual parameter. So what's x? X is this array right here. And what's y? Y is currently 3. So I'm actually modifying x sub 3 at this point. Notice that that would not have happened had y been evaluated when I did the parameter passing, but that's not what happens. I send the variable with its context. And so what we see happen is x sub y, which is x sub 3, gets modified and turns to 5. And now we need to return, and we can't just pop the stack here, because before we pop the stack, we got to take care of that pass by copy, which says, hey, the value of b needs to be copied back into the parameter that was passed into it, which is x sub 1. And so this now finally gets modified to be 3 as well. And the final output, so then we pop the stack. Maybe I should do that. Pop the stack. And the final output of this code is then 1, 3, 3, 5, 3. This being the array x, and this being the value of y. And so now we have executed that final line. So let's talk about evaluating pass by value and result, and also pass by reference here. So the pro of pass by value result is it's very easy to understand. I mean, you all are already used to it, and it's also easy to implement. It's very clear exactly what is going on. A con is that it can be relatively expensive. And the reason for this, if we go back up here, so notice in this mythical language that I've made up for this example, the array is stored directly in the stack. And I was passing elements of the array. But if I were actually passing the entire array up, and I was passing by value, then when I set up a call to some other stack, all of the array would have to then be copied in to the stack frame if I pass the entire array by value, right? So it's not just passing one bit of memory up. It could be passing a very large chunk of memory that could be copied up. And so it could end up being quite slow. You can imagine, say, having a struct in C, passing it up to some function that is just modifying one of its values, and then passing it back if it's, say, an in-out mode, pass by value result, pass by copy. And it's very expensive, potentially, to pass an entire struct up, make one modification to it, and then copy the entire struct back into the function. This is not a particularly good way of dealing with that type of data. So maybe one thing we could do is have a pointer to it and only pass a pointer, or maybe pass by reference is the better choice here. Because if I pass by reference, all I am passing in that case is a reference to the object. So if I pass an array by reference, then let's say I have a foo that takes an array called Ari, then in order to get a reference to the array, I just need to pass the address of x, and it doesn't matter how big x is to be able to pass the address. Okay, so coming back here, what that tells us is the pass by reference, a pro is that it is much more efficient, potentially efficient, only passing an address, right? A con is that it may be a little harder to reason about, because now if I pass a reference to my my variable that I've got sitting around, now I'm making changes to that variable elsewhere, and so it might be a little bit more difficult to understand how my program is evolving, especially because now, you know, we've kind of broken referential transparency here, because the same function call could be modifying. I mean, in some sense, this is a problem for out mode parameters in general, but the same function call could be modifying the internals of the parameters that I'm passing it. So this is more, difficult to reason about. Okay, and so now I want to evaluate pass by name. And in order to do that, I really need to show you the power of pass by name, because it would be one thing for me to say, hey, it's a powerful, very powerful method of parameter passing, but until you see why it's powerful, those are just words. So let's look at an example. So here is an operation I might want to do. Let's say I have an array x equal to, say, just some values, 2, 3, 1, 5. And what I want to evaluate is each element multiplied by its place in the list, and then add them all up. So in other words, I want to do like 2 times 1 plus 3 times 2 plus 1 times 3 plus 5 times 4, and get the sum of all those things. So you know how to do this in an imperative language with normal parameter passing modes. You'd write some function that looks like this, int maybe result equals 0 for, I'm going to write in a little bit pseudocode here, right? I from m to 0 up to, let's say we've got 4 of these, so let's do it. Let's pretend this is exclusive, so this is going to give me I values from 0, 1, 2, and 3, and then I'm going to say something like result plus equals, and then I plus 1, because I need to go from 1 to 4, times whatever the current value of I is, right? So I could write something like this, and it would calculate that result for me. So I could inline that. But maybe I want a general function. I want a function called sum, where in my programming language I can write this really expressive line of code that's a function call. I want to say, hey, give me the sum of I plus 1 times x sub I for I ranging from 0 up to 4, right? And so I'd like to write a function that does this. And of course, in any of the other parameter passing modes, there's no way to actually code the sum function. And the reason is that in order to do the parameter passing, this expression is going to be evaluated. And so the current value of I, if there is one, and notice even in my code, this is going to give me a variable not initialized error because I haven't even given I a value, right? The current value of I would be used, and the current value of x, and this would turn into some value. So the problem is expression evaluated and then passed. But now let's look at what happens when we use pass by name. So in pass by name, I can essentially use exactly this code over here. So let me write the code for you. We're going to define a swap function that takes in an expression and a, let's call it iter for an iterator name, and then a start and an end. And then what's it need to do? Well, it needs to initialize a new variable result to 0, and then it's going to say for iter from start to end result plus equals whatever the expression is. And so that is my entire code. And then to run it, I'm going to run exactly this code up here. Why that? Well, what's being passed in for expression in pass by name is the expression itself plus its context of what I and x mean. And what's being passed in for iter is I, 0 is going into start, and 4 is going into end. So if we actually do you can think of this almost like a search and replace. It's like iter is really I, so this becomes I. Start is really 0. End is really 4. And expression is really I plus 1 times x of I. So this expression is going to be reevaluated every single iteration of the outer loop, which means that the value of I is changing, and so the value of the expression is changing. Oh, this should have a return, right? At the end, we'd better return something. Return result. And so then at the end, when I finally return the result, the resulting value will be all of these added up for all the values of I between 0 and 4 exclusive. And so this shows you the power of pass by name, because you can make your code very expressive, right? Programs that are very readable, right? Sum up I plus 1 times x sub I for I from 0 to 4 is a pretty interesting and complicated expression. The closest thing in your experience to pass by name, by the way, is C macros. And so they are similar, not quite the same, but similar to pass by name. Now, to pass by name. Okay. So that's kind of where the power comes from, but let me call your attention to the problem. So here's a problem. Something nice about, in general, about in-out mode parameters is that you can actually write a swap function. So, and this is also, the example I'm about to show you is also a problem for C macros. So let's write a swap function. Def swap A, B, and then what we're going to do is say temp equals A equals B equals temp. And so here's an exercise for you. Let's do x of y, 3, 4, and then swap x and y. If you think about what happens with an in-out mode parameter passing method, and this will work for pass by reference, this will work for pass by copy, and this code here will work for even pass by name. Run them yourself, but at the end of running this swap, because I'm getting the values back out at the end, if I then print x, y, what I'm going to see is I'm going to print 4, 3, not 3, 4. Right, because the values will actually be swapped. So you can write a swap function in a language with in-out mode parameters. One problem, however, is if your language is using pass by name. And so let's think about what happens with a slightly different code. For pass by name, we're going to initialize an array to be 5, 2, and then we're going to initialize a counter I to be 0, and we're going to ask to swap, and let me make sure that I do this right, we're going to swap I with x sub I. Okay, so I encourage you to go ahead, this is a good practice for you, evaluate this, pause your video, evaluate this using pass by copy, and evaluate this using pass by reference to see how it works. And you'll see that what happens is at the end, exactly what you'd expect would happen. This will become 5, and this will become 0, and that will work beautifully in pass by copy and pass by reference. However, it will not work beautifully in pass by name. So let's see why it doesn't work with pass by name. So the reason it doesn't work in pass by name is what's essentially going on is that A is really I and B is really x sub I. And so this code becomes temp gets the value of I gets the value of x sub I gets the value of temp. And so let's execute this code by hand. We get a new variable temp. We put in it the current value of I. then I gets the value of x of I, which is 5, and now x of I refers to x of 5, and we get an array index out of bounds error or some kind of exception because x doesn't have an index 5, right? And so the pro of pass by name is it is very powerful. You can make very expressive programs using it. A con is, as we're seeing, it is rather unsafe. It's hard to write code that does exactly what you think it's doing. And it also, one of the things we haven't touched on is like, how am I passing? I'm not passing in strings, right? I have to pass some context for the program to be able to know where its variables are, what the variable bindings are. And the details of how you do this are a lot trickier than pass by value or pass by reference for the language design implementer. So we've got unsafe programming because it's hard to write correct code. And we've also got a very tricky to implement correctly, tricky to implement parameter passing method.